We'll start the presentation without the slides. Apologize for that. But if we can get another laptop in during the middle of it, then we'll put up the slides. There's also a copy of the slides on this presentation as well, so if you want to pull it up on your phones and look through it as we go through, you can also do that.
Hey everyone, my name is Feynman. I'm currently working at Microsoft Azure as a product manager. I'm also a maintainer for CNCF ORAS project and Notary project. We're happy to be here and with my co-speaker, Katie.
Hi, I'm Katherine Pitz. I am a software engineer for GE Healthcare. This is also my first KubeCon, and I'm speaking at it, so I'm very excited and I'm also a little nervous to be here.
Today, I also brought some very nice ORAS swags. So if you have any questions after this session, reach out to us or just ask in the room. I'm going to send these swags to you. All right, so today, we don't have a slide because technical issues, but we can still tell the story. It's not that technical. It's very friendly. So basically, we're going to share what are the challenges and problems that GE Healthcare were facing in the past and how their cloud-native transformation going with infrastructure as code, OCI, ORAS, such kind of cloud-native technologies. And I will be sharing more about the project related to ORAS, OCI, and recent updates in ORAS project. Before that, I will hand it over to Katie. So Katie, would you want to share what are the problems and challenges that you were facing in the past?
Sure, I would love to. So this is the story of how ORAS helped GE Healthcare deliver the future of patient care. So GE Healthcare has a whole suite of patient care applications, and more of them are becoming cloud native, which is really exciting for us. But currently, our model of delivery for these patient care applications has some issues, and we need to innovate on that. So before, all of our application teams managed their application infrastructure independently. It was not centralized at all. So when a hospital would order a subscription to one of our patient care applications, the process of actually deploying that cloud infra and the application to the hospital was all managed by the application team. They would have to design whatever container or package, how they were going to ship and deliver that to the hospital. They would have to write the runbook for the service engineers on how to either do the manual deployments or deploy those containers to the hospital. So these service engineers had to manage a whole bunch of runbooks, a whole bunch of instructions, and it was a very admin-heavy and manual process to deliver this software. So the time it took from order of these applications to actual use at the hospital could take up to months. Part of that is due to communication between GE and the hospitals, but the actual deployment part from the cloud infra to the hospital with all of the issues and steps that come up with that could take to a matter of days to a week, which is way too long. The hospital wants to use their application day one that their subscription was meant to in the contract. So my platform team at GE Healthcare outlined a list of problems that we wanted to solve when building our solution. The problems we wanted to solve were that every hospital has their own custom cloud infrastructure and environment configuration. So for each subscription for the healthcare application, they can choose which bundle of apps and which add-ons they want to use at their hospital. The installations of this cloud infra and applications, it can have a lot of manual steps, but also varying different processes based on what the application teams have written and designed for that application. And like I just said, each software application team uses their own methods and safety practices for deploying, versioning, updating, and deprovisioning their applications from the hospitals. And then also, because GE Healthcare is investing more and more into cloud-native applications and continuing to build more and migrate pre-existing applications to cloud-native, that just means these issues are going to snowball and become more and more of a problem. So the solution is that my platform team at GE Healthcare built a digital provisioning service tool to manage all of this and centralize it. So the basis for this tool is creating reusable base packages with custom configuration input. So each of those base packages can be composed into that software solution that the hospital is going to use, and you'll have the custom input for whatever configuration you need. This means instead of manual installations, it's all automated through our tool. There's less work and less runbook instructions that the service engineers have to deal with. They just have to use our tool. It's much more streamlined. And then also, it's all centralized under a common tool at GE Healthcare instead of having all of these various processes. So if you're looking at the slides, I could show a diagram of what that process looks like, but now instead of many, many steps it takes to deploy that application to the hospital, now it essentially just goes through our tool, and it simplifies the process a lot. And now deployment for cloud infra can take up to a few hours, depending on how complex that application is and how many packages are a part of it. So with the help of ORAS, GE Healthcare standardizes how cloud-native software infrastructure is packaged, published, and delivered. And now on to Feynman to give a little background on what ORAS is.
So in terms of ORAS, this project started in 2019, and it joined CNCF back in 2021. The idea behind ORAS is very simple. So today, you already have container images stored in your container registry. Why not just use container registry to store anything, such as AI models, Helm charts, signatures, S-bonds, policy bundles, maybe even arbitrary files in the container registry? I think the benefit is very obvious. You can leverage the centralized container registry to manage the authentication and authorization for all of those files in a central place, and you can easily distribute and manage those content in a central place. So ORAS is a fully functioning registry client which helps you to manage your artifacts just simply as you manage your container images. Thinking of how you use Docker push and the Docker pull, right? So with ORAS, it has a CLI tool, which is very easy to use. You can also use ORAS push and pull to upload and download artifacts from your container registry. So just a small survey, how many of you have been using ORAS or use ORAS? Can you raise your hand? Wow, to my surprise, we have a lot of users. Great. So we actually running a ORAS booth outside, and I'm gonna share some swags with our ORAS users later. And ORAS also provides not only client tools, we also have a bunch of SDKs. We have .NET SDK, Java, Python, Golang, and Rust. These 5 SDKs are maintained by different companies and providers and also individual developers. The ecosystem is still continuously growing, and I look forward for more developers and also providers to join our community. In addition, ORAS has been adopted by a lot of enterprises and open source tools. Open source projects like Helm, Argo CD, Notation, and there are a lot of tools. They integrate ORAS to interact with OCI registries to manage OCI artifacts from local file system to their container registry. So we have seen ORAS is going to be a de facto tool in the artifact management workflow. So in terms of scenarios that you can use ORAS, the first scenario, I think, which is also the most typical one, is the content distribution. Basically, you can use ORAS just like Docker to manage your artifacts, your arbitrary files across your local file system from the cloud to your local. And also, you can ORAS to easily replicate or copy those images with artifacts from your testing environment to production to other registries. So content promotion is kind of a very typical scenario that ORAS supported. And another scenario that we at Microsoft, we have been investing a lot, which is the supply chain security scenario. We have a lot of developers and engineers. They use ORAS to attach supply chain metadata, such as signatures, S-bond, attestations to the container image That will ensure your container image and cloud-native workloads are secure and make sure their integrity and authenticity are compliant with your company policies. Even more, we have been seeing other open source projects like OpenTofu that are extending the cloud-native workloads to multi-arc artifacts. So basically, multi-arc image management and multi-platform artifact management is a new scenario that ORAS is now supported in the community. And also the registry level backup and restore. This is something seems to be very interesting because Docker save and Docker load, that can only work on certain tags. But right now, with ORAS, you can back up, you can save the entire repositories, all of the tags and referrals down into your local file system. And you can also easily restore the tarball that you back up from your local file system to your cloud registry. And today, we have seen companies like Bloomberg, they use ORAS to manage AI models, machine learning language models in their model registries. This is the creative scenario that we have been seeing a lot of users that extend ORAS and use ORAS in a very innovative way. And also infrastructure as a code. This is a new story that I just heard from Katie. So in yesterday's container registry, we only store image layers and also the simply container images. But with OCI 1.1, the new standard, and this standard has been adopted by a lot of registries, now we can store anything, any files in container registries. So let's see how ORAS helped G Healthcare to build an automated cloud infrastructure. Katie, would you want to share more about your story?
Sure, Feynman, thanks. So now we're going to get into the details of how we actually built our digital provisioning tool at GE Healthcare based on infrastructure as code and OCI artifacts. And then if you have access to the slides, we have some more diagrams and code examples coming up, so you can reference those. But due to limited time, I may skip over explaining that since we don't have the reference. Anyways, but the foundation of our reusable base packages is infrastructure as code. I'm sure a lot of you know what that is already, but I'm going to explain it just for the general audience. So it is a method of managing cloud-native infra through configuration files. So for your cloud infra, you're essentially writing it as code in a file, as the name suggests. And the key point of this is a declarative infrastructure. This means your infrastructure is deployed as it's defined in those files rather than doing it manually. And this leads into automated deployments, which we have in our tool. And because it's deployed as defined, you are deploying the same infrastructure to any cloud environment, which lends to very high reusability, reusable packages. Infrastructure as code also tracks state management and versioning, so this helps when, with lifecycle management, when you are updating packages or applications, it's only going to change that infrastructure, it's only going to touch it when it is going to be updated in that new version. And then amongst GE Healthcare application teams, we support a wide range of different infrastructure as code tools, and part of this is to increase adoption for our platform tool. Some teams had already been writing some of their own container or package structure in infrastructure as code. Some of them have already been using Terraform. We don't want them to convert to some other tool just to use our tool. That does not make sense. So we support Terraform, we're looking into Helm, OpenTofu, and we also support some cloud provider-specific infrastructure as code as well. So now that we know that the foundation of these packages is infrastructure as code, that's what we're deploying. How are we packaging that? This is where ORAS and OCI artifacts comes in. So OCI artifacts store the content and metadata in an OCI registry. The key point is that Feynman mentioned earlier is that it's agnostic to the content type. You can put whatever you want in an OCI artifact. This means it allows packages to contain the infrastructure as code files. Great. You can also add custom metadata files and an annotations file in an OCI artifact. We use this to add deployment relevant information and then also other package metadata, which helps us when we are optimizing our deployment within our tool. Because OCI artifacts can store anything and are very flexible, this allows us at GE Healthcare to define our own common package structure for an OCI artifact, which we will enforce across teams, which will help centralize our tool, and it'll also help with creating those composable, reusable base packages to build those applications and deploy. The last thing about OCI artifacts is that you can publish these artifacts with unique tags, and again, this helps with versioning and updating applications. For OCI registries, the OCI registries that GE Healthcare can use is compliant with our privacy and security standards, and some of the ones that we use are Artifactory, Harbor, and then cloud provider specific image repositories.
Sorry to interrupt. So as the technical issue is still there, so we have uploaded our slide deck to Schedule, so you can also get a slide deck on your phone, on your laptop, if you go to the Schedule, the website, the KubeCon website, so you can still get the slide deck.
Yep, thank you. And then now this shows a visual of, like a visual representation of what the OCI artifact actually looks like with the different layers of provisioning files, so the different infrastructure as code files. Each of those are assembled into different layers in the OCI artifact. And then we have our custom annotations file, which will contain our custom metadata fields, such as solution type. And this is key because this is essentially what application is this package a part of. This is part of why our packages are composable, because you can compose any number of these packages of the same solution type and deploy that to a hospital. This is where you can specify which packages are your base ones, which ones are your add-ons, and how you can bundle them. You also specify what your provisioning type is, so what infrastructure as code tool is this code written in. If it's Terraform, then our internal platform tool knows to deploy the package using Terraform. And then there's also just a series of input parameters that are required for the different configuration to deploy that cloud infra. Then we had some code examples of what the actual manifest of the OCI artifact looks like. Currently, GE Healthcare, or our team, is enforcing the OCI spec 1.0, which is something we look forward to improving in the future and republishing our packages using spec 1.1. Just for the sake of time, I'm going to move past that. And then now that I've sort of explained what the packaging structure looks like using infrastructure as code and OCI artifacts, I'm going to go over the workflow and process of actually deploying that to a hospital. So currently we have each of our application teams still building their own packages to our team's standards, so using the configuration input with the solution type, provisioning type, input parameters, and then also they have to write their own infrastructure as code still. And then as part of that, for each of their packages, teams have to figure out how they're going to be composed when deployed to a hospital. So they have to figure out which packages are their base packages, which ones are their add-ons. That design is all up to them at this point in time. Our team helps them onboard and figures out some of those design solutions, but it's more of a teamwork rather than my team managing all of that. Once the application teams have designed all of their input for the packages, they'll use our tool to actually automate the process of building those OCI artifacts and publishing them to an OCI registry. Once those packages are published to an OCI registry, they can be used for testing, mock-ups, or in a production instance, once those packages are production ready to be deployed to a hospital, then we can start using them. Now here's an example of what the workflow would look like for actually deploying those packages to a hospital. So going back to the scenario of a hospital ordering a subscription to one of our healthcare applications. Let's say that they just want the base application and then one add-on, which is maybe an AI-powered insights add-on that they want to it. So as part of that order, the service engineer will now use our tool to input for that order. They want the base package, they want the AI add-on, and then they input whatever configuration values that are needed, that are required for those packages. Great, they put in all that input, and then our tool takes care of the rest. So they'll use ORAS copy to copy down the base package, the AI add-on package. They'll have a copy of those packages now. Then they also have the input parameters, do some processing in the back end, assemble a custom solution built on that base package and that add-on package, and now we have all the input parameter values. We also know what the provisioning type is from the metadata in the packages. We also know the solution type. And so once we have that custom solution built for the hospital, that's all deployed to the hospital, then you're done. The cloud infra is there at the hospital in time for the subscription for the application to be activated. So overall, ORAS helps GE Healthcare enable a strong future with cloud-native patient care software. And a little overview over the key points that we just talked about. So why we're using ORAS and OCI artifacts? Well, this allows us to build and publish composable, reusable software packages using infrastructure as code and OCI artifacts. This also supports adding custom metadata files to these artifacts, which help with our deployment optimization and versioning. OCI and ORAS help us because we use ORAS because OCI artifacts are agnostic to the file type, which allows us to use infrastructure as code. And then also using ORAS operations ensures safe and secure transfer and storage of GE Healthcare software artifacts with OCI registries. And then looking forward, like I mentioned earlier, we want to republish our packages to OCI spec 1.1 to align with the recommended practices, and then also the process in which we are building our artifact layers from the infrastructure as code. We want to optimize that based on file and directory size. And hopefully we can get some help from ORAS on that in the future. And now on to Feynman with a couple more scenarios from ORAS.
Yeah, ORAS can also play a lot of roles in OCI ecosystem. Today, as we still have a few minutes left, I'm gonna reserve some time for users or people who might be interested in ORAS. So I think anyone have any questions, feel free to come to that microphone and ask us. And I have some nice swags, the ORAS bags that I reserved for anybody who want to ask questions. Who want to be the first one to ask anything related to ORAS? All right.
So,
yeah, I think you can use this microphone.
Yeah.
so I'll try to speak loud.
And this also is time, so if you guys need to move on, thank you so much for listening. Again, sorry about the technical difficulties, but I hope you enjoyed.
All right, we'll squeeze it in. So if you haven't downloaded the slides, Wi-Fi was a little funky, so I noticed that you had different your own kind of artifact types within the layers in the demo that you highlighted. I don't know if that was just for the demo or if that's something that was actually implemented. And if so, can you maybe talk a little bit about your process of defining those?
Sure, let me reference that.
You mean the sample code?
Yeah, the sample layers.
Yeah.
I think that's standard with the OCI spec to have each layer have its own media type. How we went about that, I think we just did our own custom naming process. The one in the code example is just a mock-up example for a test package. So this is not exactly what we're using. I had to anonymize some of this, so.
Fair enough.
Yeah.
Yeah, thank you, Adam. All right, I think we are still there, and as we are running out of time, so if you want to talk more about ORAS, OCI, Katie and I are still there, and we still have some swags remained.
Thank you so much.
Thank you so much. You can get our slide deck from the website.